Awesome. Okay, so we're group 13 and we decided to do our project on the Lucas chest compression system. A brief overview of the product. The device was produced by the Lucas company and is used by EMS and other trained responders to replace manual CPR. It has automated high-quality chest compressions and fewer interruptions than manual CPR. It increases blood flow to the brain by 60% compared to manual CPR, and in a successful 2 hours and 45 minutes resuscitation, Lucas administered 16,830 guidelines-consistent compressions. It fits 95% of patients and has a reliability rate above 99%.
In comparison to manual CPR, the Lucas chest compression system has several advantages. The primary of those being that it is in fact its own robot designed solely for compressions. This allows paramedics and first responders to focus on other areas of the scene while chest compressions are being administered.
Okay, so for the engineers involved, there have been 3 types of engineers identified as playing a crucial role in the design of the Lucas system. First off, the biomedical engineers. So since the device is a life-saving device, there's little room for mistakes when deciding on how the device functions, since a slightly altered compression rate might make the difference between life and death. The biomedical engineers are responsible for ensuring the compression rates are exactly what they should be, that the compression depth is enough to induce an artificial pulse, but not too much to inflict damage past the patient's ribs, and of course be the ones to confirm whether or not the device can safely replace manual CPR.
Chemical and materials engineers are integral to the design. The backplate of the device must be stiff enough to eliminate the mattress effect. A stiff backplate allows all the calculated compression energy to be delivered to the patient. In addition, the actual device arm must be made out of material that delivers a firm compression and being as gentle as possible, while also including a suction element to ensure a consistent rhythm and remaining in contact with the patient. Finally, the overall weight of the device should be minimized and to increase the ease of transportation.
During the research and development of this product, we identified 4 main stakeholders in the development. First being the paramedics, then the Lucas company itself, the hospitals, and the general public. The paramedics are going to be the ones who are actually using this device, while the Lucas company is the one who's actually going to be benefiting and making profits from selling this device to our third stakeholders, being the hospitals, who are looking to purchase them for their paramedic teams. Lastly, the general public is going to be the one who's actually receiving treatment from this device and is most concerned with its success.
So first out of the stakeholders are the paramedics, who, although not engineers, the paramedics play a big part in the final design. So if the design was solely up to the engineers, they might overlook the ease of the use of the device and the urgency that comes with CPR. Of course, for the device to be a useful replacement for manual CPR, the paramedics must trust the Lucas device to continue compressions while unattended, so that they can focus on other urgent care while CPR continues.
Okay, so the Lucas company aims to maximize the profits that they make with this device. For this to be the case, they need the production of the device to be as cheap as possible and for it to appeal to the most customers. In order to achieve this, the Lucas company would want to develop a device which improves on current devices in circulation. However, it is possible that corners could be cut while making the production cheaper. By working with engineers and considering their advice, the Lucas company can develop devices that maximize their profits and are good quality. The hospital is looking for a device that will provide the best medical care for their patients while also being cheap to purchase in bulk. They want the device to be able to be as effective as possible in saving lives with the least amount of complications. The device should be easy to use for them on top of just being effective at saving lives.
So the last stakeholder is the general public. These are both the people investing in the product and using it. Those investing want the product sell, and those using the Lucas device have faith the paramedics will have one on hand to save them. Regardless, the general public wants as many of the products distributed as possible. In conclusion, the Lucas device is the product of collaboration across various fields of engineering and other fields, including biomedical engineers who design the products and the production engineers who manufacture the device. The biomedical engineers had to meet with the doctors and nurses to learn what they wanted the device to do and what was in the best interest of the patient. And they also had to consult the hospitals to see what they would be willing to pay for such a device, while production engineers had to consult paramedics to ensure that the device came in a sturdy package. That's all for our presentation. Thank you for listening.